That's the income per capita. Okay, that's the first one. That's the mean. But there is another measure of central tendency, which is the median. The median also tells us something about the center of the distribution, but in this case, it's not like a, how can I say that? Like the mathematical center necessarily, but the center in position. And you can obtain the median when you organize the values from the highest to the lowest in a list, and you find the actual middle point in that list. When the list is odd or has an odd number of observations, you go to the actual middle score, such as in this case is 6. But when the list is even, you just take the average of the two middle points. Okay? Sorry. The mode is the most common observation among the scores. Okay? One of the advantages of the mode is that you can use it not only for quantitative kind of variables, but also for qualitative. In this case, the mode is red in this population of individuals by their color. But you can also use the mode to describe quantitative variables. And especially the mode graphically is relevant because it tells us where are the peaks of a distribution. In a unimodal distribution, there's only one peak and there's only one mode. And a bimodal distribution, we have different peaks, and we can call them like the major peak and the minor peak when it is a bimodal, but you can also have multimodal distributions. Okay? Okay, so let's revisit this idea of the shape of the distribution. So a shape of the distribution is perfectly symmetrical when the mean, the median, and the mode are the same value, right? Or they are clustered together very, very close to the center of the distribution, okay? And when the distribution is asymmetrical, you're gonna see that the extreme values will push the mean towards the tail of the distribution, okay? For instance, in this case, that is a positively skewed distribution, you're gonna have the mean going to the right of the figure. Later you have the median, and later you have the mode because it's the peak of the distribution. And the opposite if in the negatively skewed kind of distribution. And this idea will make more sense at the end when we see the measures of variability. Okay, so when we should use a particular measure of central tendency, as I said, the goal of the measures of central tendency is to provide the single most representative and typical value in the dataset, okay? Sometimes you can use the mean and the mode, for example, or the mean and the median, but if you need to choose just one, the scale of measurement is a good first indicator of what you can use or not. As I said, you cannot conduct any mathematical procedure with the nominal and ordinal levels of the scale of measurement. For that reason, they are the less powerful kind of scales of measurement. So the mean can only be used with interval and ratios. You can use the median to some extent with ordinal variables, but the only measure of central tendency that can be used with all the scales of measurement is the mode, okay? And there is this idea that whenever you have a numerical variable such as interval or ratio, you should use the mean because it's the most powerful, and combined with one of the measures of variability, which is the standard deviation, it's going to give you the ability to describe in a more precise way the data and to conduct more advanced and sophisticated kind of statistical analysis, okay? But there are few cases in which you should not use the mean even if you have numeric variables. One is when there are extremely skewed distributions. Because as I said, the outliers move the mean far away, from the common values. So let's see this distribution again. Look at this one, for example. Imagine that the left extreme of the x-axis is 0 and the right extreme is, I don't know, 1000, something like that. And imagine that the median is in 15, right? If there are values in 1000, the mean is going to be pushed away a lot. It's going to be like a, I don't know, you need to do the calculation, but could be something like a 200, 300, whatever. But the rest of the individuals or observations in this imaginary example are to the left of 15. So it's going to be very problematic because you're going to have a value which is not representative at all of the rest of the population, right? So in that case, we cannot use the mean, or it's not a good idea to use the mean. In that case, we should use the median because the median is less affected by these extreme values in the distribution. And the second situation is when you don't have an actual end of one of the extremes of the data set. For instance, when you have a scale in which you have how many, for instance, the variable is how many pizzas do you eat in the weekend? 1 to 3, 4 to 5, or 5, or 4 to 5, or 6 or more. So you don't know that more how many are. So it's impossible to compute this or to estimate this mean for this case. In this case, we can also use the median. Okay. Okay, so those are the measures of central tendency. They tell us basically where is the center of the distribution, where is the peak, or what is the most common values in the distribution, what is that center of the distribution. But now we need to have a measurement of the degree to which the scores in the distribution vary against each other or between each other, and also the degree to which the scores in the distribution are clustered together or are spread out. Okay. There are three measures of variability or dispersion that we can use in descriptive statistics: the range, the interquartile range, and the standard deviation. Okay. So the range is like what is the extension, like the data that we have, how many possible values cover, right? For instance, in this example, we have a GPA of different students in the college. And what we do with the range is simply to see what is the extension of these potential values, right? And we subtract from the maximum value of X the minimum value. And what we have here, for instance, is that that range of potential GPAs in this school is 2.9 in the GPA scale. Okay? If we have a qualitative variable, the range is the number of categories of that variable. And this gives us a clue that we can use the range with the qualitative variables. Okay, one of the problems of the range is that it only takes into consideration the extreme values, but it doesn't tell us anything about what happened inside or to what extent these values are clustered together or are similar to each other. So it's not a very powerful kind of measure. So we can use as an alternative the interquartile range. The interquartile range is strongly related with the idea of the median, because you also need to organize the data set from the lowest to the highest value. And what you do with the interquartile range is that you divide the data set in 4 equal parts, and the median corresponds to the quartile 2, and the quartile 1 is the half bottom of the table. The quartile 3 is the upper half of the table. And what you do is that you subtract the value of the third quartile, the value of the first quartile to the value of the third quartile. Okay? And it's going to be a more precise kind of measurement of to what extent the data is clustered in a particular range of values, okay? In this case, for example, the interquartile range is one point in the GPA scale, because you have most of the data between 2.7 and 3.7. Actually, that's the 50% of the data is clustered in that distance in the GPA. So it's a more powerful measure of variability. But the most important type of measure of variability is actually the standard deviation. The standard deviation together with the mean are two cornerstones of all the mathematical and powerful statistical analysis, okay? And they are used in all other advanced kind of statistical methods. But before we go to the how we compute or how we estimate the standard deviation, we should remember that the standard deviation gives us an average of the scores. I'm sorry, an average distance of the score, distance of the scores between each other, and an average distance of each score relative to the mean. Okay. So how do we compute the standard deviation? Okay, the first thing is that you need to have a numeric variable, and with that numeric variable you need to estimate the mean, and we use for the mean we use the Greek letter mu, that is this symbol that is similar to a U, and you know that for this distribution or for this sample you have the mean is 3, okay? And the first thing that you do with the to estimate the standard deviation is to find the deviation of each score from the mean, okay? So you see that 5, and you subtract the mu or the mean from each score. In this case, the deviation is 2 because 5 is 2 points deviated from the mean, okay? And you have, for each score of the dataset, you have the deviation from the mean. So you don't estimate the mean of those deviations because the mean of those deviations will be equal to 0. So remember a symmetrical distribution, and we said that in a symmetrical distribution, 1/2 of the observations will be so 1/2 of the data of the distribution will be equal to the other side, right? So what we do is that if we subtract one side from the other side, we're going to have 0. That's what we have here in the average of the in the average of the deviations, right? We have exactly that situation. For the reason we don't use the average of the deviations. We need to square the deviations in order to be able to estimate something that is meaningful, okay? And the average of that squared deviations is what we call the variance. In this case, the variance is 2. And in order to have the standard deviation, we need to take the square root of the variance. In this case, is 1.41. And this value tells us that on average, each point will be 1.41 distance from the mean. And you can see that it makes some sense. If this is the mean, 3, this score, for instance, is 4, which is close to 1.4. This 2 and 2 is also almost 1.4 a distance from the mean, which is 3. Okay. Okay, so this is the final the final time that we're gonna visit or revisit this idea of the shape of the distribution. So, as I said, the mean, which is represented with the Greek letter mu, and the standard deviation, which is represented with the Greek letter sigma, are the two most powerful indicators of the shape of the distribution. The 68% of the data will be concentrated or clustered together to like a one standard deviation, higher or well, like a plus one standard deviation or minus one standard deviation. Okay, and the 95% of the data, so basically all the data, will be within two standard deviations. Okay. That information also is relevant for describing the location of a score relative to the mean and the standard deviations, or relative to the rest of the population, or right? For instance, we can identify typical cases or typical values, and those typical values are within one standard deviation of the data set, or we can identify outliers that are values that are far beyond two standard deviations. Okay. For instance, this is a way in which we can combine quantitative and qualitative kind of research. If we put all the countries here in terms, I don't know, of crime, we can see that maybe, or better, if we are talking about, this is a better example. If we have the rate of homicides of all developed countries in the world right now, we have that, I don't know, maybe Germany, Japan, Canada, and other countries are in those typical cases, probably few, like a low rates of homicides per year. But the United States tend to be or tend to have a higher rate, so is far away from the most typical or the most representative cases in the developed world, right? So in that sense, the United States tend to be an outlier in terms of homicides or rates of homicides per year. So this is a way we can combine quantitative descriptive statistics and qualitative kind of research. Okay? Okay, so to end, we can use measures of variability for different scales of measurement. We can only use the standard deviation, which is the most powerful, with the interval and ratio scales of measurement, similar to what happened with the mean and the median. And the range is similar to the mode. You can use it with nominal, ordinal, interval, and ratio. Okay? Thank you so much for watching this video. This is the most important topic about the first part of descriptive statistics. So remember, we have talked today about univariate analysis, and we reviewed some of the key concepts of univariate analysis. For instance, how to interpret, estimate, and select the measures of central tendency, how to interpret, estimate, and select the measures of variability, which are the range, the interquartile range, and the standard deviation, and how to use both kind of measures to describe the shape of the distribution. Okay? It is important to keep in mind that we have two ways to think about the distribution. One is like a mathematically, like a what is the, if the values are clustered together, and what is the middle point of that distribution, right? And there's another way, and is when we organize all the values such as in a list, we want to see what is the middle point of that list, and if we divide that list in equal parts, where is the 50% or whatever what we want to see. The interquartile range, for instance, is the 50% of those values in that list. Okay, that's all for now, and we're gonna mostly focus on the technical part this week, especially in R. And I think this is just a review, just to keep fresh what you want to know or what you need to know about the measures of central tendency and variability and the shape of the distribution. Thank you so much.